Welcome everyone to another exercise in this workbook statistics. This time we're going to focus on the topic of probability theory. Let's have a look at the exercise. Here we have 41% of all students of an elite university passed their placement test. The test consists of two parts, a personality part and a work-related part. 61% of all students passed the work-related part. Then we have three exercises on these informations. First off, what is the probability to pass the personality test if the work-related part has already been passed? Assuming that someone passed the personality part and the probability to pass this part is 46%. What is the chance that this person passes as well the work-related part? And finally, what is the probability that someone passes at least one of the two parts? And we could add or both of them. Well, let's work through the three parts step by step. Let's have a look at the first of the three exercises. What we're looking for here is actually conditional probability. And that is in detail, we want to know what is the probability that someone passes the personality test under the condition that he passed the work-related test. For this, we have some information from the text. We know probability of passing the work-related part is 61%. The probability of passing both parts of the test are 41%. That's actually everything we need, because then we can use the formula for the conditional probability to actually calculate, well, the conditional probability. That is, we take the probability of both events occurring, divide them by the probability of what here the condition is given as. So we divide by the probability of passing the work-related test. If we insert our values, we get as a result here 67.421%. So for someone to pass the personality test, if he already passed the work-related test, are roughly 2/3 or slightly more than 67%. Well, that was already part 1. So let's continue onwards with part 2. Here in part 2 or B, we have what we want as the probability of passing the work-related part if the other part already has been passed. So it's just the other way around as compared to part A. And well, whenever we have something like this, that's actually a good indicator that here we're going to need the theorem of Bayes. But before, well, what information do we have? We know the exact opposite probability. That was part A. Here we got a result of 0.6721. We also know from the text of passing the work-related part as 61%, passing the other part being 46%. Well, we have all the information we need, because if we use the theorem of Bayes, it looks like this. Just the probability, the conditional probability where these two have switched, times the probability of what has been here, the condition, divided by the probability of what is here the condition. What's the condition in the probability we're looking for? Well, we have these three numbers actually written down up here, so we're just going to insert them, giving us an end result of 89.13%. So there's roughly a chance of 89% that someone passes the work-related part if they already passed the other part. Well, that was part B, so let's continue with part C. In the third and final part C, what we're looking for is the probability that the participant passes either the work-related part or the personality part or both of them. That's always something which is written, in this case, as a union of the two events. Well, if we have a union, that's usually an indicator of using the addition theorem. For the addition theorem, we first need the probability of this event occurring, then the probability of that event occurring, and then the probability that both events will occur at the same time, or have both occurred. Well, first and second part we already know from the exercise text, and we also have the third information which we need, the probability of actually passing both of those tests, which here is 41%. Well, that's everything we need for the addition theorem, which in this case simply looks as adding the two absolute probabilities and subtracting the probability that both events occur. Well, if we input these numbers here, what we get as a final result is 66%. So the probability that someone will pass at least one of these two tests, or partial tests, is 66%. Well, that's then everything there is to this part of the exercise and to the exercise as a whole. So I hope you enjoyed it. I say goodbye and see you next time.